Hello and welcome to yet another video of Cornerstones of Math. Today we are continuing the recurrence relation series and we will solve another recurrence relations of a basic type. So it says find the nth term of the sequence an defined as follows. Problem A, a1 equals 1 and an plus 1 equals 2 to the power of n times an for all natural numbers n. And problem B, a1 equals 3 and an plus 1 equals n plus 1 over n plus 2 times an for all natural numbers n. Here they are recurrence relations in the form of an plus 1 equals fn times an. The general method of solving this type of recurrence relations is as follows. For the first one, we have this recurrence relation. Now let us substitute n equals 1, 2, 3, and so on, all the way up to n minus 1 to see what happens. So we have a2 equals 2 to the power of 1 times a1 when n equals 1, and a3 equals 2 to the power of 2 times a2 when n equals 2, and a4 equals 2 to the power of 3 times a3 when n equals 3, and so on, until we have, when n is substituted by n minus 1, we have an equals 2 to the power of n minus 1 times an minus 1. Then we simply multiply them. Then as you can see, a2 cancel out, a3 cancel out, a4 cancel out, and so on, and an minus 1 cancel out. So we have an equals, we have a1 here, then we have times 2 to the power of 1 times 2 to the power of 2 times 2 to the power of 3, so on, times 2 to the power of n minus 1. Here a1 equals 1, so we have an equals 2 to the power of 1 plus 2 plus 3 plus all the way up to n minus 1. Using the formula for the sum of natural numbers, we have an equals 2 to the power of n minus 1 over 2. And this is the answer. For the second one, we do the same. If we substitute n with 1, 2, 3, so on, until n minus 1, we have, first, when n equals 1, a2 equals 2 over 3 times a1. Then when n equals 2, we have a3 equals 3 over 4 times a2. And when n equals 3, we have a4 equals 4 over 5 times a3, and so on. And finally, for n minus 1, we have an equals n over n plus 1, an minus 1. If we multiply them, terms will cancel out, so we have an equals, we have a1 times 2 over 3 times 3 over 4 times 4 over 5 times so on times n over n plus 1. Here it is given that a1 equals 3, and notice that we can cancel out numbers here as well. So we have an equals 3 times 2 over n plus 1, so we have an equals 6 over n plus 1. And this is the answer for the second problem. In general, for recurrence relations an plus 1 equals fn times an, the nth term an can be found by a1 times the product of the ratio ak plus 1 over ak from k equals 1 to n minus 1. Or we can write it as first term a1 times the product notation pi from k equals 1 to n minus 1 of fk. And that was all for today's video. Thank you all for watching. If you haven't seen my previous recurrence relation video, please go check that video. And also don't forget to hit that like and subscribe buttons. And as always, I will see you in another video.